Hey YouTubers, I'm sure by now you've heard of these rocket mass heaters and rocket stoves, and you've probably heard about how efficient they are. And like one guy, he was supposed to, he had a wood stove and it burned 4 cords of wood in a winter, and yet then he made a rocket stove and burned like a cord, right? Um, the idea behind them is to keep the fuel exposed to oxygen and high heat at the same time, and for a longer period of time. Basically, there's problems with like campfires. I'm not sure if you're like up for an explanation of how these rocket stoves work, but you're gonna get one if you want it. So here we are. Let's call this a campfire. It's a very poor drawing of one, but one of the problems with this is most people know that wood or whatever you're burning, generally that isn't what is actually burning. What's happening is wood is being heated up to a high temperature, and when that happens, it emits a bunch of different gases. Let's see here. They emit 40% hydrogen, about 40% carbon monoxide, which burns, and then you got about 3% methane, 17% carbon dioxide. That's the gas that burns. But then, of course, you also have embers and carbon particulates that come up, and they also burn if you can get the gas hot enough, right? Well, anyway, the problem with fires, right, is the air comes into the fire and up into basically the flames, right? And then they burn those gases. The flames have like radiant heat, and they heat up the wood, and then the gases, they burn at that point. But then when you have fire, when you have a lot of heat, there's a problem with that. The heat expands the air dramatically. That's what makes a car run. It pushes the pistons down. But anyway, the air it pushes out and it becomes much larger, and it weighs the same amount. So the result is it rises, right? So then you have a lot of heat in the flames, and the air rises, and then it rises up out of the flames, and so you get a lot of air coming in, and you only really have one hot spot. It may be a couple of feet or so, and then basically the fuel that's unburned and particulate matter and carbon monoxide and many different gases, they're just wafted way up into the air, and they collect as soot on things, and basically it's just, unless you have like a really nice hot fire with really dry wood that's like going good, you're going to get a good deal of smoke, and you'll get particulate matter and stuff like that. And then, of course, for the same a given amount of heat, you'll have to use a lot of wood, right? Well, anyway, and then of course, the bottom of the flames, they're like ashes, or the bottom of the fire is full of ashes. But those ashes, in some circumstances, could be burned, but you'd have to like blow on them or something. You know how when you blow on hot coals, they glow brighter and then they emit a lot more heat? Well, anyway, those are sort of trapped down by the cold earth, and then you just get a lot of ashes and all that. So a campfire isn't super efficient unless you happen to have a lot of really dry wood around. Well, anyway, some bright boy, I think he might have been Benjamin Franklin, but he might not have been the originator of the design, came up with the idea of confining the fire in a cast iron box, and then limiting the speed at which the air could enter the fire, right? And then and then basically packing it full of wood, and then cranking the damper down on the exit and the inlet, and then the fire burns more slowly. But the problem is, when that happens, the temperature tends to drop down to like 400, 500, 600 degrees, and when that happens, you can't burn a lot of what the wood produces. You can burn the really good stuff like the hydrogen, that certainly burns. The carbon monoxide, it has a higher temperature of burning, so it will burn somewhat. Methane, it'll of course burn, but then you got wood particulate matter and carbon particles and whatnot, and they need a high temperature to burn and a lot of oxygen. And oftentimes these stoves, I mean, they work great on the inside, but they produce a significant amount of smoke, and all that smoke could be used to heat the house. Only the thing is, the fire has to be really hot for that to happen. And if you basically burn the fire a longer time at a cooler temperature, I mean, it's just not as efficient. You need more wood to heat your house. But then, not too long ago, somebody came up with the idea of a rocket stove. What happens is, this is one style. This is what they call a J-tube rocket stove, but they also have the straight-in type, where you just shove the wood into the thing and you have a little platform that holds the wood, and then air comes from underneath and then goes through the fuel, through the wood, and then up the chimney. But basically, the chimney has a property or a characteristic that is very important for the rocket stoves. What it is it's very, very insulated. They've got like vermiculite usually, or basically the tube is either made of fire brick or steel or something, but they've generally got a significant amount of insulation around it, and that causes the fire to, of course, you get a lot of heat, right? And then the heat stays confined in the J-tube for a longer period of time as it rushes up. And what happens with this, this is the J-tube style, but what they do is they take wood sticks and whatnot, and they sort of toss them down in here like so. And then air is pulled into the stove like so, and it's pulled down past the fuel, and then the fire occurs at the bottom of the fuel, of course, but then it doesn't really go out. It continues to burn all those gases and particulate matter and all kinds of those things that were generally turned to ash, and the draft, the air being pulled through, even blows on the ashes or the coals of the wood, and then it hits this J-tube, and it has this big circular pattern of fire, basically, and it mixes all of the the particulate matter and all the carbon pieces and all of the carbon monoxide, and mixes it all together at really, really high temperatures, about 1200 degrees, and then that causes it to burn all of those components down, and then it basically turns the whole mix into what you end up with is basically carbon dioxide and water vapor. So it and then basically the flames come out the top, and then people can stick like a pot or something on the top of it, and then it blasts out like a rocket. Now, the properties of gases, when they heat up, they expand many times, and you have like maybe a cubic foot being sucked into the J-tube here, but since it heats up to like 1200 degrees or so, or 1000 or whatever, but basically when that happens, one goes in and 10 or 10 or 10, 12 times of the volume comes blasting out, and it ends up looking very much like a rocket. Well, anyway, and because it's so hot, even though the chimney is fairly short, it's vastly lighter. So, for example, if you have 1 cubic foot going in there, and then it's 10 cubic feet coming out, right? Then that means that those 10 cubic feet are so much lighter than that 1, right? That it basically it's basically shoved in at cold, and then it's vastly lighter here, so it really rises up and it draws well. And that's another reason why it kind of looks like a rocket. But anyway, it comes blasting out of the J-tube, and then you've used vastly more of the fuel, and you've used it vastly more efficiently. And then basically after the fire burns down and everything, what you're left with is a very fine gray ash that's easily swept out of the J-tube, and then you're ready for your next fire. Or not. You can probably burn many different fires in one of these things over the months, and then you'd basically be able to, you get much less ash, let's put it that way. So that is the main advantages of a rocket stove, and I think I'll probably continue this video on a part 2 and explain a little bit how these rocket mass heaters that you might be hearing about on YouTube, how they work. And basically they start with a J-tube style rocket stove like this, and then they just put a few additional things onto it. So I will go ahead and stop this video here and then go on to the second video.